We just said the sentence for 6. So 6 should actually say, this is fine. It got cut off. 6 should say sine inverse cosine of 2 pi over 3. You should have known cosine of 2 pi over 3 is way too easy. So let's all do 6 together. I'm going to quit letting these people in if they can't get here on time. So for 6, the sentence, does everybody agree that on the outside we're trying to find the angle?
Yeah.
Because the inverse is on the outside, right? Find the angle between what, since it's sine? Since it's sine, look where the angle is. Negative pi over 2 and pi over 2. Very good. Whose sine, because we're still talking about the angle out here, is going to equal the cosine of 2 pi over 3. A lot of y'all are messing up on these types of sentences. Can't let him in because he didn't turn in his review. Can you text Daniel for me, Sharon? Thank you.
Oh, well.
Ask him if his review is turned in because last time Miss Poole checked, it wasn't.
Miss Poole,
Yes.
even if the angle is inside the parentheses, you would still do the angle between, like say sine was in the parentheses, you would still do the angle between negative pi over 2.
So if it said cosine of sine inverse 2 pi over 3, the sentence would change like this. You would say find the cosine, because that's what's on the outside, of, and then you look inside, of the angle, and it would still be between negative pi over 2 and pi over 2 because the angle is with sine. You look wherever the inverse is, and that'll tell you what interval to use.
Okay.
Okay, good question. He did? Okay, I'll let him in. Thanks. All right, are y'all okay with this sentence? Because this is where a lot of y'all were messing up. On the test, do we have to type the sentence in? No, you're just picking the right one. I did make them very tricky, so you best believe this one will say, find the angle between 0 and pi, whose sine equals cosine 2 pi over 3. One of them says, find the angle between negative pi over 2 and pi over 2, where the cosine equals 2 pi over 3, because some of y'all keep leaving off the sine. I made them very tricky, so make sure you can pick the right sentence, okay? All right, so to actually evaluate this, I need to do the inside first because it's a composition. So who can tell me what the cosine of 2 pi over 3 is? Good job, y'all. -1/2. So now we're just trying to find the angle between negative pi over 2 and pi over 2 that has a sine of -1/2. So what angle has a sine value of -1/2? Negative pi over 6. Very good, girls. So if you joined late, I know it didn't say sine inverse on your test review. It should have. It got cut off for some reason. My people at home that use the Google Doc, yours had sine inverse up there already. All right, and then I was asked to do number 7. So what happens right here with the tangent inverse and the tangent? They are going to cancel. Anytime you take the inverse of its regular function, they cancel. Inverse functions cancel. Now, what you have to look at is what we were trying to find. So your sentence for this one would be find the angle, because the angle is on the outside, right? Between what? What's the angle with? Good, it's with tangent, so it should be between negative pi over 2 and pi over 2. Whose tangent equals what's on the inside. So tangent of 7 pi over 4. Y'all okay? Okay. So we know the tangents cancel when we're trying to evaluate. Is 7 pi over 4, because that's what I'm left with, is that between negative pi over 2 and pi over 2? No. So the answer is not just 7 pi over 4. You have to rewrite it so that it's in between negative pi over 2 and pi over 2. Let's draw a graph. What quadrant is 7 pi over 4 in? Okay, quadrant 4. It's right there in the middle, right? Okay, it's not gonna be up here. I have to look in quadrant 4 or 1 because it's odd, correct? Okay, it's not gonna be up here because the tangents in quadrant 1 are positive. What are the tangents in quadrant 4? Negative. So how am I gonna write this angle down here so that it's in between negative pi over 2 and pi over 2? There you go, just negative pi over 4. Good work. It is negative because the tangent is negative if it's in quadrant 4. All right, do we want to check the rest of the ones from section 1?
Yes.
Okay. Ooh, let me do this. We'll check a couple at a time. Don't forget the negative. So pay attention, like for this one, the sign is negative, so it's got to be in quadrant 4, which means it should be a negative angle. Okay? If you do forget the negative on the test, I always give you all half credit for mistakes like that. So how I grade y'all's tests, I don't grade them person by person because then I would be inconsistent because I wouldn't remember how much partial credit I give y'all. I go question by question and it pulls up all of y'all's answers.
I'll be completely honest. I don't know how I got 5 over 3, or negative 5 over 3 for 4, but can you go 4?
I haven't shown you 4.
Oh, yeah.
That's 3 that you can kind of see. That's okay. And I can scroll it down if everybody's good with 1 and 2. Trying to smooth my hair because it's humid as mess in here. And I gotta go straight to this wedding rehearsal after school. The humidity is not my friend. So there's 3 and 4. Do I need to do 4 still, Chris?
Yeah.
Okay. Are you okay with the sentence?
Yeah.
Okay. So if you do the inside first, what angle on the unit circle has a cosine of negative 1/2? And remember, it's got to be between 0 and pi. Pi over 3, but if it's negative, it should be in quadrant 2 because it's even. Good. So what's the pi over 3 in quadrant 2? Good. So all you're doing now, the inside just equals 2 pi over 3. So all you're doing now is finding me the tangent at 2 pi over 3. So remember your tangent trick. If the denominator is 3, it's just square root of 3. But it's in quadrant 2, so it's got to be, there you go. Does that help? Yeah. Okay. Any questions, people at home, on 1 through 4?
No, ma'am.
He said no, ma'am.
Why is the where we're looking from 0?
Because cosine is even, so it's going to have y-axis symmetry. So it'll flip between quadrants 1 and 4. The graph will be symmetric. So that's where you want to look. That's where you have your first continuous wave. All right, I'm going to go to 5. We already did 6. So there's 5. And you'll see on mine, I like wrote off to the side what you should be asking yourself. So is 7 pi over 6 in quadrant 1 or quadrant 2 because the cosines cancel? No. So then I drew 7 pi over 6. I knew it was in quadrant 3. And we're talking about cosines. So in quadrant 3, the x's, the cosines are negative. So where between quadrants 1 and 2 are the x's negative? Quadrant 2, so that's how I got 5 pi over 6. And I wrote all that down so you could see the thought process when you're studying this weekend. I tried to write out all my stuff. Are we good with 5? Okay, I'm gonna keep scrolling. If somebody's not, just let me know. I'll leave it sitting there. There are 7 and 8, which we already did 7, so there's 8. I just got really sleepy and sad about my coffee again. Kevin's in here hitting the woe at me. Y'all know who can't woe? Miss Sparrow. A girl does her arms in like a circle. I'm like, what are you doing? It's literally here. That's it. Stop doing too much.
Miss Poole,
Yeah.
why wouldn't you just end with square root of 3/2?
Why wouldn't you just end the square root of... So the cosine of pi/6 is square root of 3/2. We're trying to find the secant, which means you have to flip that.
Oh, okay.
So you do use cosine to figure out what like ordered pair you're at, but then you have to flip the x to find the sec.
Okay, thank you.
You okay? Miss Sparrow teaches history. She's my best friend. One of them. All right, if we're good on the top section, I heard number 9 from the middle section. What else? 12. I feel like we should have been okay with 11. I can show you my 11. You can check it. What about 10? Does anybody need to see 10? Yeah? Okay, so 9, 10, and 12. I figured I'd have to do a lot out of this section, which is why I started at 9:30 instead of 9:45, so we should be good. I was about to ask what this folded up piece of paper was. It's the fake cell phone. Fake cell phone. All right. Number 9. I'm going to zoom it in as much as I can. A lot of you struggled with this one, which is absolutely okay. There's not one this difficult on the test, but there is one similar to it. It's just not as many steps. I'm hoping everybody saw that we could try to manipulate the left side. We're not touching the right side. It says establish the identity. So we're proving these identities, okay? On your test, there's not a way for me to like put in questions where you're having to prove stuff. So there's a problem where I already did the identity and you have to fill in the boxes justifying. Okay. And then there are a couple where I give you like the left side and I say simplify it down as far as you can go. What is it equivalent to? Does that make sense? Okay. So if you look at the left side, we are adding 2 fractions. Does everybody agree? I saw a lot of you try to write this first one as cotangent, but look at what you're trying to get on the other side. Cosecant. What do we know about cosecant? Not inverse. Reciprocal of sine. Good. Y'all interchange those a lot. It's the reciprocal of sine, right? So, I don't know what this is popping up in my corner. Go away. Okay. If I can write this left side with all signs and somehow make it be 1/sine, then it would match cosecant, right? Okay, so let's try to do that. These are already in sines and cosines, so I don't want to necessarily rewrite anything. So let's go the fraction route. How do I add 2 fractions? Get a common denominator. So does everybody agree that these 2 have nothing in common? So how do you make them the same? So the common denominator, what you're saying, Grace, would be sine theta times 1 minus cosine theta. So you just multiply them to get a common denominator. Everybody look, I'm going to multiply this denominator and numerator by 1 minus cosine. A lot of you came to Zoom yesterday and the day before for help on this one. And then I'm going to multiply this denominator and numerator by sine. Good. Do you guys remember doing that in Math 3 and Math 1? I hope. We're just getting a common denominator, Chris. Do you agree to add these 2 fractions? I got to have a common denominator, which means these 2, sine of theta and 1 minus cosine, they have nothing in common. So I'm going to multiply each one by the other to make them a common denominator, okay? All right, so I got my common denominators. Now look at your numerators. We can go ahead and multiply sine times sine, and what am I going to get? Sine squared theta, good. But look at the one on the left. What am I gonna have to do here since I'm multiplying by 2 terms? Distribute? Yeah, so negative cosine times 1 is negative cosine. Negative cosine times negative cosine is positive cosine squared. And then I was adding them, so I brought down the plus sign. What questions do we have so far? Because some of y'all look puzzled. I just got a common denominator. So my justification was common denominator. And then I said simplify. Cool. All right, next step, you should notice that it now says at the back part of the numerator, cosine squared plus sine squared. What do we know that equals? 1. So now you're left with negative cosine theta plus 1 over sine theta 1 minus cosine theta. And our justification here is a Pythagorean identity. Because I rewrote cosine squared plus sine squared as just 1. What do we notice now? You don't have to distribute anything. You don't have to take it out either.
It can cancel out.
What can cancel out, Ann? I think that's what they were trying to say.
1 minus cosine.
Everybody look, because a lot of y'all got puzzled. If I give you negative 4 plus 1 and then 1 minus 4, are those not the same? They are. Addition is commutative. You can switch the order as long as you keep the signs with where they're supposed to be, right? The 4 is negative, the 1s are positive. Those are the same thing. Take a look at these two. The 1 is positive, the 1 is positive. Negative cosine, negative cosine. So what can I do with the numerator and denominator? Yeah, she said we could cancel them out, and she is right. So I'm gonna put cancel / simplify. You could say either one of those, I would take it. So what are we just left with now? What's in the numerator? 1 over sine theta, which we know is the same as cosecant because they are reciprocal identities. Very good. Was it really that bad? No. What was the hardest part? Getting a common denominator, which you actually learned in elementary school. That's okay. A lot of you guys didn't, like when you got to middle school or high school, your teachers were like, here, have this calculator. Notice I rarely ever have them out because you should be able to do this without one. If you take calculus, you don't get a calculator. Take it at Pitt, you won't get one. You don't need one. There's actually more computations in pre-cal than calculus. Are y'all good with 9 now? Okay. So look at 10. If these things don't stop popping up, Lord Jesus. All right, look at 10. A lot of you chose to try to mess with the left side. Let me talk to you about the left side. You can't rewrite this with just cotangents and tangents without having to expand it. A lot of y'all are not great at expanding. Look at the right side. Can I write cotangent as sines and cosines? Can I write tangent as sines and cosines? So I chose to mess with the right side, and what I did first was I changed cotangent to cosine over sine, and I changed tangent to sine over cosine. And why am I allowed to do that? Quotient identities. Very good, kiddos.
Morning.
Good morning. Yes, please. I'll come right out there. Quotient identities. Okay, so now while I'm going to get my coffee because I'm already spilled mine, what do I have to do to be able to subtract 2 fractions? So can you guys get a common denominator? Get a common denominator, simplify it, and y'all tell me what happens. I'll be right back. And then it got kicked over. All right, common denominator. Did you guys multiply this one by cosine over cosine? Multiply it by that denominator? Okay. Cosine over cosine. And then did we multiply this one by sine over sine?
Okay, now I get it.
You multiply it by the other denominator because they have nothing in common. All right, so this would now be cosine squared theta minus sine squared theta over sine theta cosine theta. All right, look at the other side. Well, let's justify it first. So justification, what did we just do? Common denominators, tell me that. But then we did simplify. You can abbreviate. D-E-N-O-M is what I put, not D-E-M-O-N. It's not demon, it's denom. Somebody wrote demon on theirs and I was like, yikes. Now look at the left side. Look at what you're trying to get. I'm trying to get 1 minus 2 sine squared. I already have 1 sine squared, so let's look at this cosine and see if we can write it as a sine. Can I write cosine squared as a sine squared? Okay, what is it? Good. 1 minus sine squared theta minus the sine squared theta that was already there over sine theta cosine theta. And why were we able to rewrite that? Pythagorean identity. Anytime it's squared and you're rewriting, that's a Pythagorean identity. Thank you, lady. Y'all okay? Okay, so look, Chris, if you do negative sine squared theta minus sine squared theta, doesn't that give you 2 sine squared theta? So they already match. You would just rewrite this as 1 minus 2 sine squared theta. And then your justification would be that you simplified. Oh my God, there we go. I just ran out of room.
Wait, the green is on one side, right?
The green is, this is all the right side. I didn't touch the left. You can't touch both sides if you're trying to prove. Establish means prove. So we're not solving, we're trying to prove one side can match the other. People at home, any questions on 10?
So when you multiply the denominators out, they just cancel out one of them, like one of the sines and one of the cosines, like in the first step.
No, I'm getting a comment. So let me give y'all an example. Pay attention, kiddos, because some of y'all. What is the common denominator that you can get between 3 and 4? How do you know it's 12? Okay, not fact. There's a least common multiple. So think about it this way. If it was 7, 6 minus 5 twelfths, 6 goes into 12, so the common denominator would be 12. So in this case, we would only have to multiply top and bottom of this one by 2, and we wouldn't do anything here. If they don't go into each other and don't have anything in common, you multiply them together to get a common denominator. So if I saw this denominator was sine and this one was cosine, they don't have anything in common. So I've got to multiply this one by cosine and this one by sine. You multiply them by each other. They don't cancel. That's just sine theta, cosine theta for both of them.
Okay.
Theta, cosine theta minus sine squared over sine theta, cosine theta. So then since they have the same denominator, you can just combine it to this. Is that what you were asking?
Yes, ma'am. I was just confused because but it's not the numbers I kind of confused when it's just the sine and the cosine.
I got you. I combined 2 steps. That's what Grace was saying. Thank you, Grace. Squared theta. I'm gonna mess with the left side. I hope we all agreed with that. Let me start there. What's 1 plus tangent squared theta? Secant. Thank you, Grace. So this is just cosine squared times secant squared. That is a Pythagorean identity. I'm glad y'all can use your notes. Because only one of you told me secant decently fast. Y'all did not make flashcards like I suggested, did we? Go. I would. Kevin, you didn't tell me secant quickly, which means you don't know it. Make a flashcard. Write it on your mirrors at home. Put it on your hands. Do something. Don't put it on your hand the day of the test. All right, Pythagorean identity. Now, everybody knows, I think by now, that cosine and secant do cancel each other out. But can you tell me why they cancel each other out? Very good. Okay, kiddos. Now I'm not mad at y'all anymore. Good job. Secant squared is the reciprocal of cosine. So you could have said reciprocal identity. And so from here, if you simplify, it's just cosine squared over cosine squared, which is just 1 equals 1.
So I
We're done.
I changed tangent squared into sine over cosine, but I still.
Oh, this is what it-
So if you change tangent squared into sine squared over cosine squared and then distribute, you will get the same thing. It's just more steps. Those Pythagorean identities, when you see something squared, if it's a Pythagorean identity and you can go ahead and use that, it's going to be faster. But you could definitely rewrite tangent as sine squared over cosine squared and distribute.
I have a question. Can I skip the reciprocal ID and then just say inverses cancel each other out?
No. There, you have to, and they're not inverses. You have to write the reciprocal. You are proving to me. So there's not skipping of steps. Even over here, this is not me skipping a step. I just subtracted the fractions without writing them separately.
Okay, thank you.
You're welcome. All right, let's check 11. And then I'm going to see which equations y'all need me to do at the bottom. 11 wasn't bad either. So what's the other way you could have done 11? It's just like the one we just did. Uh-oh, kiddos. That's fine if this is how you did it, but how else could I do it if it's tangent and cotangent? Reciprocal is good. So you also, for your first step, could have done this. And told me that that was just 1 minus sine squared in the next step. But instead of quotient IDs, if you did the Brown way, it would be reciprocal IDs. Does that make sense, y'all? You got at least 2 ways to do all of these. So on your test, in Delta Math, it would be really hard for me to make like 10 different boxes and you have to prove each step because everybody would do it differently. So that's why on Delta Math on the test, I just give you this and I say simplify it or rewrite it all the way down to tell me what it would equal. So that being said, if you stop here, is that simplified all the way down? No, I'm gonna take points off. It literally, I'm pretty sure it says like simplify to like the smallest possible value or something like that. I can't remember how exactly I worded it. But are y'all okay with 11? We've had one like 11 and 12 before on worksheets. And 10. The only new one was 9. All right, 13, 14, 15, 16. Which ones do I need to do? 16?
13.
Can you do 14?
Yes. I don't know. I'll try my best to do all 3 of those. 13, 14, 16. Can I show y'all which part of 16? A? Okay. Can I show y'all 15 and 16B then? So that we already have those? And then if I need to, I can keep recording after the bell rings, but I've got 11 minutes, so I might be able to do it. What'd you say? So the interval 0 to 2 pi, sorry, I'm on the wrong one, is where you put pi over 3, 5 pi over 3, and pi. General solutions are general formulas. So they should say plus, or they could say minus 2 pi k. You will typically see plus 2 pi k, but we did talk about this in a Zoom. You can also go 2 pi the other way around, and the values will still repeat. So you can do plus or minus 2 pi k. You don't have to put both. I did add the button at the bottom on the test though that says plus or minus, so you can click that if you want to. You don't have to. If you do put plus or minus, I'll probably throw in some extra credit because it could go both ways. But typically you'll see the plus because we don't usually go backwards around the unit circle. On the test, it will say general formula, parenthesis, S, in case there are more than one, because you have to put all three of these.
You have to do plus minus.
I'll give you extra credit if you do. I'm gonna do 13. They aren't paying attention. That's why I had to yell. Don't make me pull up my coaching voice, right, Kelly?
Right.
Dan's like, you are not scary. Woo! But y'all used to hate it when we'd be like, hit the stairs. All right,
Oh yeah, I used to hate that. Oh my God.
16B. Not when you have to run them because you didn't do what your coach asked you to do. All right, check 16B. Kevin, check 16B. Chris, check 16B. I'm gonna start throwing markers at y'all like I do to my freshmen. Shh. Good, check it.
I got 165 degrees and 285 degrees.
Okay, shh, listen. If you take the sine inverse at the beginning,
I didn't get it. I got just 45
you didn't let me finish. If you take the sine inverse at the beginning, you will just get 45 degrees because you're supposed to follow your inverse function rules, correct? On the final exam, the answer would be 45 degrees. They're not going to put all three. Now, you should know that there's going to be more than one answer because a sine graph looks like this, correct? So if it asked you for all possible answers, where could you go to find the other ones? Desmos, so listen to me, children. If you go in Desmos and you type in y equals sine of 3x minus pi over 4, and then you go type in y equals 1 and see where they cross, wouldn't that give you all the solutions? Yeah, so you can check yourself like that on the test. It should, if it's on the unit circle, which what this one is, it should give you radians. It shouldn't give you decimals. Let's also talk about this really quick. Do y'all know how to transfer between degrees and radians and Desmos? Let me show you, and then I'll do those problems my people asked for. You can, but Desmos will convert it for you. All right, kiddos. I hope my freshmen aren't this chatty today. Y'all aren't being bad, you just chatty Cathy's. It is Friday the 13th. Children always act wild. All right, looky. Everybody sees this, right? So if it's on the unit circle, it'll give you the pi's. So there's 9 pi over 4, like you said. Okay. But let's say that the answer choices or Delta Math asked you for degrees. Go to settings. Change your settings. I got to move my Zoom people. Nope, still in the way. There we go. Change your settings down here to degrees. You're just going to have to zoom out. It's literally right here. I'm sorry that my projector sucks. But it's right here at the bottom. Radians, degrees. All right. And then I'm going to change my window because I can't see very far. So let's do 0 degrees because I don't really care about the negative angles to 720. Is that fine with y'all? So I can see it go around multiple times. And then I don't know why the Y's are at 100. So do you see how I'm just like changing my windows and stuff just like a regular calculator? So let's do like -5 to +5. Look how pretty. So degrees, it would be 30.2 something, so 30, because it's pi. Whoa, wait a minute. Oh, my equation isn't in degrees. BRB. This would be 3x minus 45. Hey. Here you go, y'all. So 45 degrees, everybody look. If your equation is in radians, you got to leave the mode in radians. If you want to put in 45 degrees instead of pi over 4, It'll be at 45 degrees, 165 degrees, which is what you said, 285 degrees, that kind of thing. So you can change the mode. Okay. Okay, sounds good. All right, I'm gonna try to do these ones y'all asked for. If you have other questions, you need to come to office hours. They're not office hours today because I'm in a wedding. So if you need help, I'm gonna hold a Zoom on Sunday. You just need to reach out to me so we can figure out what time everybody can do, and also on Monday. I'm gonna fly through these so my people can see how to do them. All right, are we paying attention? Because if you say, wait, what, or make me backtrack, I'm not gonna have enough time. So we're ready. All right, subtract square root of 8, right? So this is 4 cosine theta equals negative square root of 8. Divide by 4. So that's cosine theta equals negative square root of 8 over 4. Okay, we should know from math 2 that you can simplify the square root of 8. Square root of 4 times square root of 2 gives me square root of 8. What's the square root of 4? So does everybody agree this is just negative 2 square root of 2 over 4? So look at the 2 and the 4. What does 2 over 4 reduce to? 1/2. So this is just going to be cosine of theta equals negative square root of 2 over 2. So where on the unit circle, now listen to me carefully, all values, not just between 0 and pi, all values, where the cosine is negative square root of 2 over 2. X's are negative in quadrant 1 and 4, or no, 2 and 3, right? Okay, hang on. Shh. I'm asking a question. X's are negative in quadrant 2 and 3, yes or no? Yes. So the pi over 4 angle, because that's where the x is square root of 2 over 2, the pi over 4 angle, where it's in quadrant 2 and 3, would be 3 pi over 4 and 5 pi over 4. So those are your solutions on the interval 0 to 2 pi. How would you write the general equations? Y'all forgot the most important part. Y'all better put theta equals or you're getting points off because it says formula, which means an equation. Theta equals 3 pi over 4 plus or minus 2 pi k, or theta equals 5 pi over 4 plus or minus 2 pi k, because the period of cosine is 2 pi. All right, there's 13. I'm flying. Somebody said 14, I believe. Does everybody see how it says cosine on the right? Does everybody see how it says sine squared on the left? Can you factor if they are two different trig functions? No. Now listen to me. You cannot rewrite this one as sine, kiddos. You can't do that. It's not squared. That is not the Pythagorean identity. You can't touch the one that's just plain cosine. Which one do you have to rewrite? Sine squared. That is your Pythagorean identity. So you could have done 2 times 1 minus cosine squared equals, and I'm going to go ahead and distribute 3 minus 3 cosine theta. Distribute here, so that's going to be 2 minus 2 cosine squared theta equals 3 minus 3 cosine theta. I'm going to move everything to the right so that my cosine squared isn't negative. Is that okay with y'all? I just got to get it all on the same side instead of equal to 0 to factor, right? All right, I hope we're paying attention. Some of y'all haven't been writing this whole time. That's scary. Minus 3 cosine theta, and then I'll end up doing 3 minus 2, so that would be plus 1. Yeah. Okay. Let me know if that doesn't make sense to you. People at home, unmute, ask a question. This is why I didn't want y'all talking so much so I could get through them all. But at the same time, it's not my test, so. That's how that would factor. I'm going to let you look at it and ask me a question. So we're going to end up looking, while you're looking at my factors, for where the cosine of theta is 1/2 and the cosine of theta is 1. Okay. Stay on, my Zoom people, in case y'all have questions. Cosine, good, Chris. Cosine is a half at pi over 3, or where else is it positive? What quadrant? Where the x is positive, 1 and 4. So what's the pi over 3 in quadrant 4? 5 pi over 3, good. And then the cosine is 1 at 0. So you should have gotten 0, pi over 3, 5 pi over 3. The general solutions, you would take all those and just plus or minus what? 2 pi k. Good, because it's cosine. Now remember on the test, if it's tangent, it would just be plus pi k. Yeah, you would still do, so you do theta equals 0 plus or minus 2 pi k. So you could have 0, 2 pi, 4 pi, 6 pi, 8 pi, and it keeps going. 16, I'm going to put up for anybody that needs to see it. All my writing is there, so just take a look at it. I will also put this on Canvas. So online kids, unless you have a question, y'all are good to go after you check this one.